And a big thank for the organizers. Oh, yeah. A big thank to the organizers because it's really an enjoyable event. So what are we going to be talking about? So we're going to speak about a new Python course. And of course, the main question is, what? Already? A new one? One more? And I need my glasses. So the project is called PyEduFR, and I will give a brief description of what the project's about, and then speak about the design of the project itself. So why yet another Python course? So first observation, well, everybody in this room is aware of it. There is a big rise of computation and data for science and beyond, and therefore everybody is running to try to train students, staff, and so on, about computing, data processing, machine learning, and so on. And so there are major efforts for this. There are MOOCs, and I'm just citing a few ones, French ones for once. So we have online platforms, we have libraries of teaching resources, we have software carpentry. And if you look at universities, you have a flurry of introduction to Python, and probably, if it's like in Paris-Saclay, just inside Paris-Saclay, there is at least 10 different group of people doing 10 different introduction to Python, which are basically cover the same ground, which is basic programming, a bit of NumPy, computing and visualization. And many of them are using kind of same technology. So you may wonder why in practice there is so little reuse? Why is everybody reinventing the wheel on this side? And there are some intrinsic reasons, some barriers that make it harder. One is due to computational, maybe kind of a French or European thing compared to maybe in the US. So for example, let's think about teaching mathematics in the US. Every STEM student at some point will have done Calculus 1. Of course, there may be 3 or 4 variants of Calculus 1. There will be Calculus for engineers, Calculus for mathematicians, and a few variations. But basically, it's a very well-defined core that's defined everywhere. And there are textbooks. And when you deliver such a course, basically, you choose among the existing textbook which one you like best, and you base your course on this textbook. In France, we don't really have this textbook tradition. Actually, there is this tendency to think that you are going to be judged on the material that you are going to write yourself. You think you are expected to write the material and that you are going to be judged on this. I've got a colleague in Germany that phrases it quite nicely, saying that a German professor would rather use the toothbrush of a colleague rather than his course material. And with that also comes the idea that, hey, it's my material, I'm not going to give to others. So the open science tradition in education there are still some progress to be done. There are also some more technical barriers like language. It's harder. There are a lot of material in English, but we want to teach to younger students that maybe are not fluent in English, so maybe we want to have French. And then, of course, everybody has his own taste about how to educate. Then, of course, there are technological barriers, so that's kind of a difference between just a calculus course and a course in programming, because, of course, you need to choose the programming language, you need to choose libraries, you need to choose computational environment. Do you prefer to use VS Code, Jupyter, you name it, whatever infrastructure you have. And all of this is evolving very quickly. So in math, when I teach a math course, I can reuse textbooks that are 40 years old, and often they are the best ones. For us, it doesn't work that well because they don't exist or they are not up to date, or just the technology that they use, for example, is not there. And of course, again, personal taste, Emacs, VI. Hey, who is using Emacs in this room? VI. Yeah, I'm getting old. All right. And of course, there are a diversity of public. You don't teach the same way when you have complete beginners, experts, possibly a mix in the same room, whether you're teaching to mathematics, biology students, and so on. And there is a question is how to grab their interest. and how do you fit their specific constraints. And practical things are like, how large is your class? Are you going to deliver lectures separate from recitations, or is this an online course that students are going to follow? And of course, and that's probably the main point, is time pressure. We all agree that we should be reusing and we should write good material that is reusable, but in practice my course is tomorrow and I need to deliver and it's good enough. Okay, so we're trying to do something, and from the bottom there. So of course a lot of us were frustrated by this because it just feeling that we are always running and we are not investing. And then earlier this year, Pierre Rogier, who is there, sent an email to one of our mailing lists saying, hey, we are going to refactor our training material. Maybe it would be best if we wouldn't just do it inside Grenoble, but if we would try to do something a bit larger. And then a lot of people say, yeah, we should do something. Maybe it's the occasion to finally take the time to try to do a bit better. So the important part here is and you. So the people in bold are not are people that are at PyData. So we have Pierre, we have Chiara. Do we have anyone else in the room? No, not yet. Bebe will be there later today. Okay, so group of people getting together, and what are we trying to do? We're trying to share first among ourselves. Let's start small, and then two others. Open educational material, and of course, when you do something like this, you have to choose a scope so that you don't dilute everywhere. So for now, and the scope is mostly defined by the people that are there yet, but if more people come, we can certainly enlarge the scope. So for now, the scope is around Python, and you have to define what means around Python, but let's say briefly around Python. Most of us are interested in training in higher education and research. And then what should be the scope? French speaking, although we write quite of our material in English, so maybe this barrier is not really meaningful, but that's just what we have been aiming for. And we want the material to be open because we want to foster reuse. And a good compass there is just to reuse what people have been thinking for data. So I'm going to use the same principles, the FAIR principles. So we want the material to be findable. We want it to be accessible. So when you speak about teaching, accessible has two meanings. You have just the accessible, that you can actually find it, get it on the web somewhere. But you also have the accessible in terms of someone with a screen reader can actually use it. And everywhere it's going to be in both meanings. Whereas for data, it's not that relevant, that difference. We would need to have two different terms, by the way. It would be easier to distinguish, but that's how life is. And interoperable and reusable. Okay, and of course, there is the usual thing. It's so bad that there are N courses. Let's solve this by having N+1 courses. So we'll see if we are questioning ourselves about this. Are we just making things worse or not? We'll see. Time will tell. Okay. So current status. What content do we have? So the most advanced one, because we had just had a lot of material that we could import and put together, is an introduction to programming with Python and Jupyter. So it's this kind of computing 101. You will learn about loops, functions, blah, blah, blah. A tiny bit of NumPy, tiny bit of pandas, and so on. So we have about 80 Jupyter worksheets. It's building on previous works in PyData and elsewhere. And it's been used at least for 2 classes for now. And next year, we expect it to be used with something like 400 students. We want to have something similar in English, targeting master students. And we're not yet sure whether we want something that is different or actually if it should just be a translation of the first one. Is it really a different target community? We have to experiment. And then the other thing where we do have material, it just needs to be assembled. It's training for advanced Python programming, and then it's a lot about good practices, tooling for distributing, and so on. So in particular, in Grenoble, they have a lot of material that will be there. We have infrastructure. So we have a website, which of course will help for findability and accessibility. We have a public forge. Of course, when you start working in a group like this, you need to agree on a bunch of different things, and everyone has his pet tool and etc. So Pierre was very keen on using Mercurial, so we are using Mercurial, and if you want to know about his motivation, please discuss with him. With a mailing list, again, we have offering conventions. And that's not easy, because just saying, hey, we're just writing everything in Markdown is not the end of the story. You want to have some common style. You want to be using style both in terms of how you phrase things, but also style in terms of how you lay out things, so that the student moving from one part of the course to the other feels at the same place. And you need to agree on all of these. So we have pretty lengthy offering conventions, and that took quite some interesting discussion. And we have a bit of tool. Whoop, what did I do? Oh, I clicked. No, it was not what I meant to do. And a good thing is, for once, we do have some institutional support. So first, the group is, we are taking the occasion to create a group for Python at the CNRS. So we have 2 CNRS work groups about computations and about software development. And in there is now a Python group. And we have some funding from this Saclay School, which is funding for training students AI at Saclay. So there's funding here to organize workshops, but also to pay a few people, to pay former students to actually contribute and things like this. All right, so design, how do we attack this? First thing is, because we're targeting a diversity of students, we need to be engaging, and in particular because we have students that either are completely illiterate, or worst, that have had past experience with programming and bad past experience with programming. And it's like mathematics, basically, oh no, computer science is not for me. And so you have to get them back home. So first, one of the main goals of this course is to deliver these 4 messages. You can do it, it's fun, it's going to give you power, and really mean a lot of tools at your fingertip in your own world, useful when you do biology, when you do math and so on. And it's science. It's not something that big gurus do in their cave. It's really science behind. So let's take things. First thing, we want for them to be engaged and find fun. And of course, gamification is a natural thing here. And so here is a little example. Here we have a maze. And inside this maze, you have a little ant, and you have a door. And you want to program the ant to go all the way to the door. And so this particular maze is not difficult as a maze, but it will be interesting from a training perspective, because of course the students will first write move forward, move forward, move forward, move forward, and very soon they will feel the urge to have a better way to do it. And once the student has this urge, you can say, hey, maybe you want to learn about while loop. Maybe that you are actually going to like it. So making things very concrete in terms of something that is very natural, intrinsic to us. Speaking of accessibility, this works well for most students. So actually, I first tried this. So this is this is inspired by a tool which was designed for Fête de la Science a couple of years ago. And I was wondering if it was interesting, so I tried it on my 8-year-old daughter back then. She loved it, and then I asked myself, okay, good for kids. Now, how is it for first-year students? Are they going to think, hey, it looks so childish, we don't want this? Actually, my students loved it. And actually, even adults just love it. So that it's a little game and has some look for childish is not a problem. Of course, so a good thing, it's engaging and there is no prerequisites. Well, but if someone has problem seeing, if someone has problem with thinking in 2 dimensions, and I've had students that can't think in 2 dimensions, which just think linearly, and can do deep algebra with this, but just cannot draw, then this would be a problem. So we would need to have some alternates. But for most students, this works very well. Of course, it's not a new idea. When I came to the equivalent of this place here, so it was Palais de la Découverte as a kid, there was a computer and you could play Logo and launch a program with Logo. So that's a very old idea. We know that this kind of things, that kind of ideas works very well. And of course, we should be doing it. And many other platforms like France.UI is doing the same thing with robots and so on. And there would be one thing to do, which would be to share the same widget across all these courses. That would be a nice project. Okay. It's poor, so we want to have people do interesting things as soon as possible. So some courses start by explaining, oh, what is a bit? And once you have bits, you can start explaining, oh, I can write an integer in terms of bits. Well, that's interesting. Students should learn it at some point. But really, if you just want to be using integers, you don't need the details on how it's stored. You want to separate, you want to have the right abstraction layer. So there is a whole thing about choosing the right abstraction layer, and about doing things interesting. Using Python is great because immediately you can do images, you can do sound, you can do 3D geometry, you can do all sorts of things. We're not exploiting this enough, but yeah, typically we want to have a lot of mini projects that allow to do fun stuff. And so then comes the difficult question is, do I want to write exercises that are dedicated for mathematicians by exploring problems in math, or same thing for biology and so on? And doing this has good aspects because it makes things concrete. Oh, solving this is actually solving my problem in my world. That's how I could use it. So that's nice, makes things concrete. It also engages, you see why you're doing this. But we have also seen that it brings cognitive load. So when trying to solve your exercise, you need to both think about mathematics, or biology and so on, and the actual computer science programming problem that you have at hand. And quite often it adds cognitive loads, it adds prerequisites. Maybe actually you're going to lose some of the students that are fragile at math, so you'd better just keep them on the programming side. And it distracts. So the resolution, how we try to resolve this is by having most of the material being context-free, or relying on general context like, hey, I'm moving an ant inside a maze, so things that every student is familiar with. And then, but try to introduce quite quickly small project here and there, some examples that are rooted in the domain. Okay, so we want to convince students that this is actually science. And my main learning objective here is that students are able to rigorously analyze a program, reason on the program, and predict and control its behavior. That will be particularly important in the coming days where most of the code, well, a lot of the code, especially for people not in computer science, a lot of the code they will write actually using AI. And even if they don't write the code, we want them to be actually analyze it, to be able to analyze it and just think, oh, it looks like this chemical and it should be doing something like this. So the strategy there is to make sure to introduce concepts, not just recipes, but read the concepts, and introduce models. You can think of the memory as, and I'm not going to explain the details of how memory, there are things on the processor and so on, but give a simple model of what memory is so that I can, with this model, explain precisely what is the semantic of the for loop, the semantic of this, the semantic of this, so that they can reason the code being based on this model. So if we want to have an analog here, we want students to learn. So I don't know if you have this debate elsewhere than in France, but in France we have this big debate about when we teach people how to read. We have the syllabic approach, A, B, no, B, A says ba, and so on. Or you have the global approach, just throw words and get them to read them globally. And what we have seen is that our students tend to read programs globally. We say, oh, it looks like it's doing this, rather than analytically saying, oh, I have a for loop, okay, so it's going to do this, and then inside the for loop, it's going to do these operations. And a key tool here, in my taste, is a debugger, so that they actually not only see that's the input, some magic happened, and that's the output, so that we actually really see step by step what this is doing. And I believe the debugger is really an important tool. And there are things that could still be improved. So simplifying the Jupyter Lab interface. So there's a great Jupyter interface for the debugger, but it's more meant for developers. having a simplified version of it with just 3 buttons, step forward, step backward, stop, really just the bare minimal would help. And I would like to have it in Jupyter Lite. All right. So that was to engage. Now, from a more practical point of view, we want to foster reusability and reuse. So of course, there are the obvious things. So it's or license is Creative Commons share alike. And we tried ourselves to reuse material to see how it is to actually import material. But the main thing is, actually, the project is not about delivering free courses. It's about building a collection of learning activities. So you have to define what learning activity, but think a small narrative, possibly with interactivity, possibly with self-assessment, with prerequisites, ideally with explicit prerequisites and learning objectives. So for example, this can be an exercise, this can be a mini project, this can be a chunk of a course. And then from these, once you have these activities, then you can start building new courses by composing them together. So that someone, the point is, it's quite unlikely that you are going to reuse the course of someone else exactly as is, because it's not going to fit exactly how much time you have, what's your public, and so on. It's much more likely that you are going to reuse this worksheet and compose them together to build your own course. And the next step that we are exploring right now is to do adaptive learning. So we want not only to adapt to the teacher that writes, oh, you should do this worksheet, this worksheet, this worksheet, but actually we would want to empower the learner to go at his own pace, and maybe with a personalized experience. Oh, I'm already familiar with for loops, so maybe I can skip this part and focus on this part. Or having feedback, having feedback, let me see. Yeah, that will come. Having feedback on, oh, are you ready to engage into reading this? Or maybe you should better come back to your course and see again what a for loop is. So there are challenges. What's the right granularity? What is natural? It's not quite clear. We're experimenting. And there another challenge is that when you reuse some material, most of the time this material has some context, if not just a first sentence saying, so you have just learned blah, blah, blahs, and now we are going to. Or now that you have learned this, maybe you're ready to engage into. And so there is this big question, so how to decontextualize the learning units so that they are meaningful by themselves, and where to put all these transitions, because these transitions are important. In practice, for us, a learning unit will be just written as a markdown file. So markdown and, well, that's one problem. Markdown is not fully, completely standardized. So we have chosen the MIST, the MIST extensions to be able to write nice things like having, well, nice things. So the good thing is it's simple, it's standard. You can have learning metadata. So here is an example. So here in the metadata, I'm writing, oh, the objective of what's below is to apply functions, and I need to be able to apply for loops. And it can be interactive, so you can make it in Jupyter notebooks, and you can easily export. Well, it's nice standard format. All right. And in practice, the user environment might look like this, a Jupyter notebook. Here, the students need to do something, and you can ask AI for help. Another example, and so on. I'm going to skip this. Okay. Yeah. Yeah, just one important thing. So we have this tension. Should we be writing our material in English or French? If you have already done this, you know that having a document in both languages and maintaining over the long term is a pain. So I recommend to talk to Thiéry, which will be there this afternoon, has done an internship. And he has developed a tool that helps you maintain multilingual documents written, for example, in LaTeX or Markdown and so on, while preserving a lot of things. So it's not just you drop it to DeepL and hope for the best. Okay, thank you for your attention. So just to keep it short, what is PyEduFR? It's a community that tries to deliver fair training material. Please get involved, ask questions, and just the last tiny bit. At Paris-Saclay, I'm co-running a chair about AI for teaching and learning AI. So big thing, but we're of course going to try to focus on more specific things. if you're interested, if you're looking for a job, we will have very soon postdoc, at least 1 or 2 postdoc opening and 1 or 2 research engineer opening. Thank you.
Thank you. Thank you. Thank you. Thank you. Hello, hello. Thank you, Nicolas. Thank you, Nicolas. So do we have any questions here for Nicolas? Yep.
What's your take on user interface? Do you do this in the notebook or in Spider or idle, or is this this trade-off between cognitive load and convenience?
So that's a good question. And there will be no unique answer because, of course, when you are going to train someone on packaging, you don't really need to have interactivity. Most of the work will be done in the shell separately. But for beginners who are using Jupyter. But basically, we really mean we write Markdown files, and then depending on the kind of course, if we need interactivity, then Jupyter will be good. But if you would want to use VS Code, in principle, it should work. Yeah. No, but notebooks is definitely good for early. The only thing is you have to be a bit careful is notebooks are great for computation. And in these courses, there is always a mix. Are you teaching computation or are you teaching programming? And if you start to do heavy, like this, programming, then probably using a notebook is not the right thing to do. Or most of the time, we try to do a mix where we train the students to have to write the code in a file and have a notebook. And to separate, at this stage, I'm doing programming, so I should be doing this in a file. But right now, now that I've defined a new asset, I want to use it to run a computation. That's a computation that you want to explain extra, so you do it in a narrative. So starting full Jupyter notebook and progressively migrating to programming, separating programming and computation.
Another question? Yep.
Thank you. Great talk.
Thank you.
My question is this kind of format for a course, isn't it pre-AI era? What do you think about teaching like the basics of programming like this in our time?
That's a very good question. We definitely want to train our students to use AI and to use it as a tutor and so on. But at the same time, I believe that the core material, I want to have control on how things are presented to my students. So typically, if my students are using AI, I want this AI to use RAG and to use my vocabulary, the vocabulary I've chosen, the conventions I've chosen, and so on. So I think there's a great, and that's one of the things that we want to explore is how to combine both things. But I still want to be, especially for beginners, to be somewhat in control in how concepts are presented. Well, yeah. When you teach, you make choices, and you want the AI to respect those choices. And then very quickly, once you have set up the basis, give freedom to students to explore and go further. And anyway, we don't want more and more AI is going to feed on itself, and I think it's good to inject human, well-qualified material inside the loop.
Oh, perfect.
Yes, 2 technical questions. Are you using Jupyter Book, which is a good way to? And
yes,
okay. And ordering and maintaining a notebook is a nightmare when you want to reorder. So when you want to reorder the cells, it's very complicated.
Yep.
And so I saw that you write Markdown. Do you have a way to generate Markdown notebook from the Markdown? And if you reorder your Markdown, it will be reordered in the notebook?
So this is actually, these slides, this is a Jupyter notebook, but if you look at the name, it's a Markdown file. So I'm using JupyText, and I think Markdown, for teaching, Markdown is a great format for notebooks because it's easier to manipulate and edit. And when editing it, I'm doing a combination of switching between my editor and Jupyter, precisely for these reasons. And the other thing is keep your notebook short. It's and which fits well with our design to try to make small learning units that are reusable. So all this goes into, the shorter the notebook, the less problem you have. But of course, it's not always possible. Happy to discuss more because for us.
Okay, I think we can start the break if there are no other questions. Okay, so let's thank once more Nicolas and have a nice break.